Okay, so this is the fourth period video where we'll do 2, 5, 8, etc. And because the review is so long, I got to really be careful toward the end and make sure I don't get off and start doing the wrong problems, but we'll see. So let's start with number 2. Which of the following sequences is an arithmetic sequence with a common difference of 3? And this would be one reason why there's 50 questions, is because questions like this. So arithmetic means I'm adding the same thing each time, and I'm adding 3 each time, so that would be C. By the way, question D, is that an arithmetic or a geometric sequence? If it's geometric, what's R? Anybody want to make the case that it's arithmetic? What's its common difference? 0. So you could argue that one's either one. That's just a side note of a weird, that's not this question, but. Let's see, number 5. The sequence given by 4 times 1/3 to the n minus 1 is geometric with common ratio of, well, if you don't know, then you can write out the first 2, 3, 4 terms and figure it out. Preferably, you can look at the expression there and know that what's R equal to? 1/3. I mean, there's 50 questions. There's a few questions like that. Not many, but there's a few. And brain going. Number 8, write that sequence using sigma notation. Now let's figure out what kind of sequence it is here. We're going down by 15 each time. So a sub n is negative 15n plus what needs to go in the blank to make it work? Well, be careful. If you put 36 in there, then 36 won't be my first term. So I'm going to go 51. If you want to think of it the other way and start with 36, you can do that. But then you have to do n minus 1. And you end up with 51 minus 15n. So if you could start with 36, that's fine, but then you got to use n minus 1. If you want to just jump straight in with negative 15n, then you got to figure out like what the not missing term, but what to add to it so that you land at 36. Okay, not done yet because it wants sigma notation. So the sum of negative 15n plus 51 from n equals 1 to 1, 2, 3, 4, 5, 6 terms. Not the only way to do that problem, but probably the easiest for most. But a few people are going to go n equals 0 to 5. And that's okay. If you go 0 to 5, I hope this is more helpful than confusing, then you can do negative 15n plus 36, because when you plug in 0, you'll get 36. So either one of those answers would be acceptable. They're the same. They don't look the same, but they're the same. Number 11. The sum of the first n terms of an arithmetic series with first term negative 20 and nth term 50 is given to be 120. What is the value of n? Okay, that's a lot of words. The sum of an arithmetic series is n a1 plus an over 2. Okay, now let's see if this makes sense. First term is negative 20. The nth term is 50. The sum is 120. Find n. Oh, so it wasn't really that bad of a problem. It just, there's a lot of stuff going on. Let's see. So 120 equals n times 30 over 2 is 15. And 120 divided by 15 is 8. Because 120 divided by 30 is 4, so I think that would be 8. Number 14. Find the sum of the infinite series. Now there's only one formula that works for an infinite series. But you've got to be careful. That kind of comes with asterisk on it. It has to be geometric, and the absolute value of r has to be less than 1, meaning the terms have to be getting smaller. So are we even eligible to use this formula is the first question. Let's see, r is 1/5. So we are geometric, and r is less than 1. So yes, we can use this formula. So first term is 5. R is 1/5. So 5 divided by 4/5. Keep it, change it, flip it. It is 25 over 4. But be careful with that infinite sum formula. We are going to give you problems where we tempt you to use it when you're not supposed to use it. Number 17. An infinite geometric series has a sum. Here we go again. Oh, but we know the sum, so I guess we have to use the formula for this one. Sum is 20. The ratio is 3/5. What is the first term? This is just algebra at this point. Let's see. 1 minus 3/5 is 2/5. Hey, what do I want to multiply both sides by to get a1 by itself? 2/5 or 5/2? I thought some people would say that. I want to multiply by 2/5 to make the 2/5 cancel out. If that's confusing, then you could rewrite that as 5/2 and then multiply by 2/5. But either way, you're multiplying by 2/5. So 40/5, which sometimes better known as 8.
You're dividing by 2/5.
Because I'm dividing by 2/5 over here, so I want to multiply by 2/5 to cancel it out. One way around that would be, instead of dividing by 2/5, I could rewrite that as a1 times 5/2. And then that's a little bit more obvious that you would multiply by 2/5. But either way, you're multiplying by 2/5. Number 20, a more infinite geometric series has a sum of 2. The first term is 1/3. What is the common ratio? Okay, same formula, slightly different algebra. 2 times 1 minus r equals 1/3. So 1 minus r is 1/6. So r equals 5/6. That's just a little algebra problem. Twenty plus 3 is 23. Which of the following is false? 23. Which of the following is false? Okay, let's see. That's infinite, infinite, infinite. One of those I can tell is false right away. Do you know which one and why?
First one.
Why is the first one false?
Because the absolute value of R is greater than 1.
Yeah, R is bigger than 1. Those terms are getting bigger. So there is no infinite sum. So that is definitely false. So that's at least one I don't have to try to figure out. The other two, let's see, so 3 is false. So I've got to have 3 as part of my answer. Wait, 1 is false. What am I doing here? Let's find 2 and 3. Yeah, I don't know that there's a easy way to do this. Infinite sum, first term over 1 minus r. Be careful. As this one starts at 0, so that just means I'll plug in 0 to get my first term. So 2 times negative 2/3 to the 0. Well, that's kind of convenient. 2 is my first term. R, hopefully I can tell by looking what R is. Negative 2/3. So let's see, 2 over 5/3. Keep it, change it, flip it. So 2 times 3/5 would be 6/5. So number 2 is true. I messed up all the markouts down there. So let's try number 3. First term starts with 0, so the first term is 2. R is negative 3/4. Careful with the signs. 1 minus negative 3/4. So 1 plus 3/4 would be 7/4. So keep it, change it, flip it. That would be 8/7. So that one's true as well. So number 1 is the only false answer there. But really save some time when you recognize the R greater than 1 thing. That doesn't even work. 26. Okay. Okay, it's infinite, the ... meaning the only possible formula is a1 over 1 minus r. But that will only work if r is less than 1 and if it's geometric. Can you tell what r is equal to? Sometimes the r is easier to find out here, even though there's fractions. Because 27 times 3 would be 81. 4 times 4 is 16. And then maybe I should verify that. 9 times 3/4 would be 27/4. So that's almost correct.
Wouldn't that be negative?
It would be negative because they're alternating signs. So a1 is 12. 1 minus negative 3/4. 1 plus 3/4 would be 7/4. So 12 divided by 7/4 would be 12 times 4/7. Kind of a weird answer, but it's there. 48 over 7. I'm just killing the infinite series sums here. Go into infinity, so again, my only option is a1 over 1 minus r, but only if it's geometric and only if r is less than 1. R is 1/4, so we're definitely good here. How do I find a1? for this, for any. Like, what am I going to plug in?
It's 2.
2 on this one, because that's where I start. So be careful, that A1 is sometimes misleading. Doesn't mean plug in 1, it means plug in the first. 2 times 1/4 to the 2 minus 1. 2 times 1/4 would be 1/2. So my sum is 1/2 over 1 minus 1/4. So 1/2 over 3/4. Definitely keep it changing, flipping on that one. 4/6, also known as 2/3. I feel like we're overkilling the infinite sum here. 29 plus 3 is 32. Order the following from least to greatest. Okay. It's just a dumb way of making us work 3 problems, right? Like, unless there's a... No, they're all different, so there's not really a good way to... I don't think. Although 30 minus 2n, that starts at 30. That one's going down, so I thought it would be least, but it starts higher than the others, so I don't know. I don't think I have an option other than adding them all up, like using the formula for each of them. So they're each arithmetic, so we should back up. How do I know they're arithmetic? Because there's a 2n, a 3n, there's not an exponent. So this one we're adding 2 each time, this one we're adding 3 each time, this one we're subtracting 2 each time. Now I see part of why they picked this problem. If we go from 11 to 25, how many terms is that? From 11 to 25. So you're like 15. Good. 15 terms. A1, again, that's a little bit tricky because it doesn't mean plug in 1. It means plug in the first term. So 22 minus 5 is negative 3. A sub n means plug in the last term. So 50 minus 25 is 25. So let's see, 22 divided by 2 is 11. So that's 15 times 11. Like, I could answer that now, or I could just leave it there and see if I need to answer it. Like, maybe it's so obvious which one's least and greatest. 0 to 15. How many terms are there from 0 to 15? Everyone's nervous now. Like, 16. I plug in the first term, I get negative 10. I plug in the last term, 45 minus 10 is 35, all over 2. So that would be, I'm going to do the 16 and the 2 this time. It's 8, 35 minus 10 is 25. I guess I'm going to have to figure these out. 8 times 25 is 200. 15 times 11 is 150 plus another 15. So 165. And then lastly, from 3 to 20, how many terms are there? 18. First term is 30 minus 6, 24. The last term is 30 minus 40. That's negative 10 all over 2. So that'd be 9 times 14, which is, I don't know what 9 times 14 is. Looks like it's 126.
Isn't it going to be negative 14?
No.
Oh, wait.
No, 24 minus 10. Okay, least to greatest. So 126 is the least. So we're starting with 3. And then we go to 1, and then we go to 2. So answer choice B. It's like really that problem is going to be worth 2 points because we had to do 3 different formulas, and we had to find 3 different things in each of the 3 different formulas. And then we had math to do in each of the formulas. 35. Oh, this is where we had a mutiny last period. Write an explicit formula for that sequence. So my first thought is, well, is it arithmetic or geometric? Well, it's definitely not arithmetic because I'm adding 3, adding 5, adding 7, although that's definitely a pattern there. It's not geometric, right? Because I'm not, 3 times 2 would be 6, but 6 times 2 is not 11, so it's not geometric either. So Avery's answer is, I don't know. Okay, there were 2 other, not really types, but patterns maybe. And that was when we saw perfect squares show up. Whoops, 1 squared is 1, last I checked. And perfect cubes, sometimes those are important to recognize. Okay, so does it match any of those? I mean, it doesn't match exactly, but...
What will those be on there? The cubes.
I think I found it. Something close to it. Right? N squared gets me close. N squared would land me at 1, 4, 9, 16, 25. Plus 2 would get me there. Couldn't do that on your own? Okay. The good news is there's only 2 free response questions. And they're both having to do with binomial expansion, which means if you get one like that, it would be multiple choice, which would mean you just look at your answer choices and plug in and see which one works. Right? Plug in n equals 1, 2, and 3 and see what lands at 3, 6, 11. $38. Ooh, 2 n's in there. Let's see here. I should start with the bigger one. 2n plus 1. Factorial would mean I'd go down to 2n. And then I'd go down to 2n minus 1, but I'm going to stop there. Why am I going to stop at 2n? Because that's what the top is. So the 2n factorials can cancel, and I'm left with 1 over 2n plus 1. $41, and then we're done. Which of the following is the coefficient of x cubed in the expansion of 2x minus 3 to the 5th? Okay, so I know there's going to be 2x to some power and negative 3 to some power. And I know it's going to be 5 factorial up top. And then the 2 bottom numbers will be whatever powers go on the 2x and the negative 3. So what power should go on 2x to make x cubed show up? 3. Which means what should the power on negative 3 be? Why 2? I got to add the 5, so that one's got to be 2. And then that means my 2 denominators over here are 3 factorial and 2 factorial. Okay, so 5 times 4 times 3 factorial So the front number is 1. The binomial coefficient is 1. The Pascal's triangle coefficient is 10, excuse me. So tempting to put b, but that's not right. Because I need to cube 2x. That would get me 8x cubed. And then I need to square negative 3. That would get me 9. And so I put all the coefficients together, and I get 720.